Hey, Science Nines, and welcome to our discussion today on topic 1.3, the distribution of matter in space. Today, I want to discuss three things: stars, I want to discuss constellations and asterisms, and I'll also be quickly discussing galaxies as well. The majority of today's discussion will be based on stars, how stars are formed, and how they live out their lives, and how they eventually they die. They have a life cycle just like everything else in the universe. Nothing is forever. So let's discuss that first. Let's discuss stars. Well, stars are hot balls of glowing hydrogen that are found throughout the universe, and they release a huge amount. Each one will produce huge amounts of electromagnetic energy. We pretty much, in our neck of the woods, our local star, the sun, we see it as visible light that's coming from the sun. But of course, the sun is producing lots of other types of electromagnetic energy: X-rays, UV rays, and we discussed ultraviolet radiation earlier this year as it pertained to the ozone layer. So these stars throughout the galaxy are producing huge amounts of this type of energy, and that is sort of making each of those areas of the universe sort of go round and round. Each of the planetary systems that go around a lot of these stars, because a lot of these stars do have planets around them as well, including our own solar system here, which we'll be discussing later in this unit. So, how many stars are there in the universe? Scientists estimate that there are roughly 1 billion trillion stars in the universe. That would be a one with, I'm going to count this off the screen. I see 3, 6, 9, 12, 15, 18, 21 zeros. So 1 times 10 to the 21st power. That's what 1 billion trillion stars. That's what that number actually looks like. For the most of their lives, stars live out in what is called the main sequence. And this is a little bit beyond this course, but if you take more astronomy later on, maybe you take Science 30 with me in grade 12, we discuss a famous diagram or chart that was created by a couple of scientists by the name of Hertzsprung and Russell in 1910. They basically determined that there was a relationship between the temperature of a star and its general color. They found that the hottest, brightest stars tended to be blue stars, and the coolest, dimmest stars tended to be ones that were more red in color. Our sun, kind of in the middle of the pack there, it's a yellow star, so it's not one of the hottest stars by any means, and it's not one of the coolest stars either. But they basically created what was called the HR diagram, which is down here. And you can see down the middle of the diagram, there's this thin line that goes down the middle. That is sort of considered to be the main sequence of stars. These are stars that are basically living out their lives day to day. Stars down here and stars up here are either in the process, they're in the process of they're in the process of shutting down. Stars that would be up on this side of the graph here are either expanding or getting larger. Some of the ones down here are getting smaller and cooler as they begin to basically fade out. And I will get to all of that today. But the main thing you want to take from this diagram is that for the most of the life of a star, it lives out the majority of its lifetime in what's called the main sequence. And depending on what the color of the star is when it's in the main sequence, that determines how hot it is. Again, blue stars being the hottest, red stars being the coldest, and yellow sort of in the middle. And that's our sun. Our sun is sort of kind of a happy medium star in the universe. So we've got sort of an average yellow star in our neck of the woods. How does a star form? Well, there is a life cycle, and I'm going to walk you through all of this. The first start for all stars, you have to have what's called a nebula, which is a concentration of interstellar matter, which is essentially gas and dust particles. These nebula are floating all around the universe, all over the places, all over the place in the universe, and these are generally called nurseries. These are called star or stellar nurseries where stars are formed. If you want to see more about nebulas, take a look at this video. It'll explain what nebulas are in much greater detail than what I'm doing here today. At this point, the interstellar matter begins to coalesce. It begins to get sucked in by gravity, and atoms of interstellar mass cause a small area of the nebula to begin collapsing into a rotating cloud. That cloud will eventually, under its own gravitational force, will eventually become a spinning ball, and its mass and its temperature begins to increase as the gravitational forces get stronger, and it begins to glow, and once it starts to glow, we refer to it as a protostar. That protostar is sort of the start of the star, And roughly at 10 million degrees Celsius, that's the temperature that basically causes the hydrogen that's forming inside this star to begin fusion into helium. And that reaction between, so basically two hydrogen atoms fuse into one helium atom, So you've got two hydrogens right here. They each have one proton, are going to fuse together into one two-proton helium atom. That process of hydrogen fusion is essentially what powers the star, and that's what basically ignites the star, and that begins its release of large amounts of energy, radiation, as I mentioned, in the form of electromagnetic energy, and that is when the star is actually born. Here's an example. This is a great shot here called the Pillars of Creation, which was taken by the Hubble Space Telescope. This is a great shot of a stellar nursery. You can see a place in the universe where these stars are actually forming inside of these nebula. Now, at this point, depending on the size of the star is going to undergo one of two life cycles. If we have a low mass star, like our very own sun, that low mass star is going to basically live out its life in the main sequence. And by the way, what I'm discussing right now would be on this side of the graph. This is this side here for a sun-like star that has low mass, a very small star, and our sun is considered to be a smaller star in the universe. It's going to live out its life in the main sequence, and then at some point, it's going to begin to run out of hydrogen to fuse into helium. Once the fuel supply in that star runs out, it's going to undergo a series of events that are going to basically lead to the shutdown and the death of that star. The first stage is going to be called the red giant stage. The star will actually expand outward and will actually, as the fuel runs out and gravity begins to sort of shut down a little bit inside of the star, you're going to get basically the star expanding out, getting larger, and it's getting red, so it's getting cooler. At this point after this, you're going to have what's called a planetary nebula form. And as I mentioned, nebulas are going to be the birthplace for new stars. So as this star basically expanded out and basically released a lot of material into the surrounding area, as the star begins to collapse, a lot of that material gets left behind the star. And then that material, eventually, if there's enough of that material from enough dying stars in the area that are basically that are dying, that can become a large nebula, which in turn can lead to the birth of new stars. So it's sort of kind of this kind of recycling program that's going on in the universe, where one star's death can eventually lead, if there's enough stars dying in an area of the universe, that stars can be reborn from the material from the dying stars in that area. So that planetary nebula then forms around the collapsing star, and then inside that planetary nebula, you're basically going to see, as the star collapses in on itself, you're going to get what's called a white dwarf. Now, if you want to learn more about white dwarfs, watch the video up here, and they'll walk you through all the goodies about a white dwarf and what makes them kind of cool. But it's basically going to be a very small star in comparison. It's going to be, so basically this is my sun. It's going to expand out to a red giant, and it's going to collapse into a very small white dwarf star. Eventually, when all the reactions end on that star, you're going to be left with what's called a black dwarf, which is basically a dead core star that's basically got no life in it whatsoever. If you've seen the Avengers movies, if you've seen, it would have been the Infinity War film, the first of the two-part one with Thanos there. There's a part in that movie where Thor has to go to get, he has to go to the forge. This essentially the star that basically forges his hammer. Eventually, he's going to get his axe forged there as well. But when he gets there, the star is essentially completely dead, completely dark. That would be essentially a black dwarf at that point. A black dwarf, though, right now are theoretical. Black dwarfs can basically, we've never actually seen a black dwarf. And the reason for that is it takes so long for these stars to cool down. The universe is simply not old enough to have black stars actually having them formed. So if there are any black dwarfs out there, we haven't seen them because they are very rare, because the universe is simply not old enough to have a star that basically cools down enough to become a black dwarf. So these black dwarfs are hypothetical, but that is sort of the end result of a white dwarf. When it completely shuts down, it would then become a black dwarf in the sky or up in the universe there. Now that's what would happen if it's a normal star. If it's a very large star that's living out its main sequence, then you would have a different chain of events. A massive star, which would have a high mass, a very large star. So something like the star Betelgeuse that's in the constellation Orion would be an example of a large mass star. It basically doesn't just become a red giant when it expands. It's because it's so big, it becomes a red supergiant, which is a much, much larger star than the red giants that are being produced by the average or low mass stars in the universe. That super red giant then, again, will, as it collapses back in on itself, all that mass and material gets left behind. And what you get left with at that point is called a supernova. And that supernova does actually cause a massive shockwave or explosion. And if this supernova doesn't destroy the star, two outcomes are possible. So in a lot of cases, when the red giant collapses in on itself, the supernova has such a massive explosion that it actually destroys the star completely. But if the star doesn't get destroyed by the supernova, one of two possibilities can occur. If it's a regular large-sized star, like a large star, but not one of the biggest stars in the universe, it's going to form into something called a neutron star. Watch this video, really cool about neutron stars. To put it in perspective, a neutron star is estimated to be roughly, when it collapses, that red supergiant that's billions and billions of kilometers in size, it will basically condense back into a star that's only 20 kilometers in diameter. That would be roughly from here to St. Albert. That would be the diameter of a neutron star, and it would be, all the mass of that star would be condensed into that 20 kilometer diameter. That would give gravity that is roughly 2 billion times stronger than it is on Earth. A teaspoon of that star, by the way, of a neutron star, would weigh roughly 1 billion tons. So 1 teaspoon of matter off of a neutron star would literally weigh about 1 billion tons. It would be 1 billion tons in mass. That's what happens to most of the massive stars if they survive a supernova, when they collapse. Most of them turn into neutron stars. But there's a very few that have a large enough mass, the biggest stars in the universe, when they collapse in on themselves, they become black holes. Watch this video on black holes to see what all the goods are about a black hole, because they are very fascinating interstellar objects, and they are basically the gravity in them is so strong because we're collapsing even closer in than on the neutron star. The neutron star maybe collapses to 20 kilometers. This one might collapse in even further. Well, it has to collapse in even further. The gravity is so strong that light itself can't even escape the black hole. So how do we know they exist? Well, we have actually seen a black star for the first time. In 2019, scientists had the first photographic evidence of a black hole. It was located in the galaxy M87, which is 53.5 million light years away. The black hole's event horizon shows light bending around in a perfect loop around it. Images here, take a look. But again, if you wanted to watch more about black holes, that video I just suggested you watch, give that video a watch about black holes, because there's some really cool stuff about black holes and how they actually warp the space around them. They do some really cool and crazy things, at least hypothetically, because we've never actually been to a black hole. Right now, there aren't no black holes that are close to us, thank goodness, because that could be some big problems if we have black holes in our neighborhood of the universe. All right, that's it for stars. The rest is actually pretty straightforward. What is a constellation? Constellation, you've probably heard the term before. Constellations are official groupings of stars that are arranged into patterns in the sky. There's only 88 of them that are actually recognized internationally. Some of them would include Orion, the Hunter, Scorpio, the Scorpion, Leo, the Lion would be another one. There's all the zodiacal constellations that are in the sky. One that you're probably most familiar with might be Ursa Major, which is the Big Bear. And that's, it's shaped like a giant bear. But this is where things get a little weird. We don't just have constellations, we also have what are called asterisms. Asterisms are unofficial groupings of stars that form patterns in the sky. And in this case, Ursa Major has an asterism inside of it. Ursa Major has probably the most famous pattern of stars in the sky, the Big Dipper. the Big Dipper is not officially recognized as a constellation because the Big Dipper is several stars that are found within the bigger constellation Ursa Major, just like the Little Dipper, which is another famous asterism. It's located within a larger constellation known as Ursa Minor or the Little Bear. So there are official patterns in the sky known as constellations. There are unofficial patterns in the sky made of stars that are called asterisms. So that's the difference between a constellation and an asterism. And last thing, once I can get off this slide, because apparently it is not moving off the slide for me, which is really weird. Let me see if I can get this thing working one more time here. Apparently it is stuck. I'm going to do a manual reboot off the main iPad here today. Let's see if I can actually get this thing to work this time. Yes, it's drawing out the constellation for me. This takes too long. The last thing I'm going to discuss here as I'm waiting for this iPad to actually do what it's supposed to do is I'm going to be discussing galaxies. Galaxies are essentially massive clusters of stars in the universe that basically are found all over the place. And if you put enough stars in close proximity together, very tight proximity together, you get what are called galaxies. And galaxies can come in all shapes and sizes. There's all sorts of shapes for galaxies you can see here. We live in a spiral galaxy known as the Milky Way. Here's a picture of the Milky Way, and it shows the relative position, if you got your notes up, the relative position of our star in the Milky Way. Just to put it in perspective, how many galaxies are there out there? The scientists estimate anywhere between 100 to 200 billion galaxies in the universe, and in our galaxy alone, the Milky Way, there's estimated to be between 100 to 400 billion stars. So that's where we got that number earlier in the lesson today about the 1 billion trillion stars in the universe. Just take your number of stars in the average galaxy, multiply it by the number of galaxies, and that will give you a rough estimation of just how many stars are out there. And then, of course, there's going to be stars, sort of isolated stars that might be out there that are between galaxies. But most of your stars are going to be concentrated into clusters known as galaxies in the universe. And then in between the galaxies is going to be pretty much sort of empty space between them. But yeah, that's basically what a galaxy is. Great shot of some of the galaxies here that have been discovered by Hubble. I'll be discussing more about these fascinating discoveries with my lesson later in the unit about telescopes and different telescope technologies that have been really revolutionizing astronomy over the last several decades. Your homework for today, now that we've covered stars, constellations, asterisms, and galaxies, here it is. Questions 1 to 3 and questions 6 to 10 on page 391 in the Science in Action 9 textbook. Join me again next time when we are going to take a look at our neck of the cosmic neighborhood. We're going to be looking at the solar system next time for topic 1.4. Won't you join me? Thanks for tuning in. And until then, have a great day.